Hello, everybody. All big accolades, but frankly, I'm just a guy who likes to solve problems. Oh, there's a poll that started. Can I just close this?
Yes, do close. I just want to remember, guys, please kindly attend this poll. It really help us to organize more data sessions. Over to you, Vijay. You can start now.
Yeah. All right. So, yeah, advantage me. I became a data scientist, going from the computer science to software engineering to data engineering, big data route. And I always asked myself, what value am I bringing to product and business? That's always my root cause. I love math, but is my math in tune with trying to simplify a solution for business? So that's kind of my advantage with the experience. I'm kind of a potpourri of everything. I'm Bhelpuri, I call myself, a little bit of everything. Um, in today's discussion, I will take you through some very exciting use cases, at least that I find very exciting. Basically, I have consulted with companies. I also, this was what I'm going to present today, or the main core of what I'm going to present today was an idea that came to me in 2012. I got to work on it in cafe coffee days and Starbucks in various parts with a couple of colleagues here and there as a fun project. And then I did apply it in a few places, and it wowed me with the results and wowed people around me with the results. Um, it is data mining, essentially, and the use cases are for drive view. There's e-commerce, RTO, RMA, and all that stuff. We spoke about e-commerce RTO last. I had introduced it in my last talk as well. Then there is a company called Dhobiwala.com. They gave me data, really smart guys, and I'll go through that use case. There's a Swiggy hackathon that I took part in. And then I've been, post my time at Google, I've been trying to dabble with a few things with probabilistic data structures and population healthcare analytics. So I'll give a brief about that. And if there's someone who's interested in further research, then I'll do reach out. It could be some open source contribution. And if you're somebody who can influence some dedicated funds, then Professor Anirban Dasgupta from IIT Gandhinagar may be interested in, at least a slew of things that could lead to some really fantastic stuff in the data science world. I'll end with one use case of distributed systems and automation. I think there's a huge opportunity. And one thing that one of my managers told me was that the victory of an engineer or a scientist is to make his or her life redundant. So the more you can automate, the more you can chillax later. So I'll talk about that use case and end basically with that use case. So my intent has always been in data science is data explainability, accountability, and subsequent follow-ups on remedies. Right, when you solve a problem for someone, you need to when you apply a remedy, did your problems from before disappear? Did new problems arise? These are questions that you need to keep track of. And I've always wanted to get closure on the analysis, the prescription, and post-prescription, whether things have really improved. I'll talk about rule-based empirical classifier. I think this is really powerful and underestimated today. But I know companies, I can't name, that they rely more on rule-based classifiers to a large extent and quite successfully compared to complex models. Building analytics much faster, extracting only the interesting insights. And this has been a thing in management science as well as in data science, as well as in statistics, that given a body of data, how do you pick out only the interesting facts in the unsupervised world with some basic questioning? And then lastly, I really want to stress on automation with data. All right, the brief idea of much of the talk today is going to be, you have a body of data in the middle, and you have analysts sitting around, right? There are analysts who are trying to make visualizations or query by country, by different dimensions, right? Get metrics by country, somebody's trying by gender, somebody's trying by age group, and so on. But to the left, whom I would call a winner, or what is ideal, is which dimension and value and their combinations fetch me the best optimal metric that I'm looking for. That's basically the idea. Instead of going dimension wise, country, city, so on, you just ask a question, a more bigger question, that based on the metric, based on the values, what do you tell me? I mean, you're asking this oracle, what do you tell me? In this use cases from that earlier diagram, I'll talk about exploratory analysis for e-pharma medicine delivery. E-laundry, that's dhobiwala.com, where it's just basic exploratory analysis. Somebody gave me data and said, hey, what can you do with it? I'm not asking you a question. What can you do with it? The second case is classification. In classification, I create rule-based classifiers on historical empirical data. E-commerce, RTO, RMA, and returns is definitely, some screenshots would really amplify and tell you what we asked of the data and what we got. The driver on hire for this company called DriveU. DriveU had cancellations once upon a time, and this is back in 2018. Very good company, very popular company in India. A lot of people who take their cars to work, and then from work end up going to a pub, don't want to drive back home, and you could get a DUI, driving under influence, and find yourself behind bars. So you book a driver on DriveU using an app, and the driver takes you home safely. So that's the company, and beautiful data, beautiful use cases. Same with Dhobiwala, some of the cleanest data I've seen in my career. Swiggy hackathon, very interesting, back in 2018. I'll talk about that briefly. I don't think I can talk too much in depth, but just give you an idea. And then classic data mining as a scientific data analyzer, and I'll talk about population healthcare analytics in big data and a computationally hard problem, like how it can be simplified. I did some initial benchmarking, but there's a huge room for improvement, and maybe a publication and some open source work that can come out of this. So I'll talk about that. And lastly, I'll talk about automated root cause analysis in large scale distributed systems. You'll get the idea of where I'm going with that. It's an overview. I put some of it to work. I could have done a little more, but the users are welcome to, the viewers are welcome to try and be creative and share your ideas, please. I mean, maybe even in the comments on YouTube, or bring it through DataHour and share it on DataHour. So exploratory analysis, a quick time check. We've taken 11 minutes. Okay. With all the sales data in e-pharma delivery, how can we monitor for interesting data? What would be interesting? How can you explain the interestingness? What would be actionable? Can analysts sift through millions of combinations of dimensions and variables to find out the top most interesting results? How would you solve it? And take a step, just think to yourself the problem. You have many dimensions and metrics, right? Many dimensions and a few metrics, maybe one or two. And the dimensions could be country, age group, gender. So this audience data, this location data, there's all sorts of things, right? It could be 20, 30 different columns. And you want to, sift through and come up with, if not a recommendation, at least find out, bubble up the interestingness in the data. So here's an actual example. I had to strike out, sorry for the ugly strikeout, but I had to strike out the supplier name. But basically, if you see this blue line, blue highlighted thing, you see the values, right? Okay, it got cut. The values got cut, but basically the values are available over here in this format. So when demand city is Mumbai for anti-diabetic cash on delivery from a particular supplier, and therapy is chronic. Yeah, diabetes is chronic, so that's why hence it's true. But basically, if you see this graph to the right, do you notice a linearity towards the last 3 points and a rise, a sudden rise? If you do, then you would see I've used standard deviation. Interestingness was based on standard deviation. We came up with a score on that, or the Z-score actually. And we also use coefficient correlation. Correlation coefficient, basically to check linearity. So by chunking data automatically 2, 3, 4 levels, 5 levels, and observing those chunks over a period of time, we could tell whether the current data point, the latest data point, was it interesting or not. If the Z-score was not high, if it was within the historical range of the new data point was within the historical range, or there was no linearity, well, then the likelihood of it being interesting is very, very small. Unless you have some idea of what to do, the linearity would be, the interestingness would be very, very small. So the Z-scores on time series for spike up and spike down, and correlation coefficient for slope of linear growth. But I was able to apply this only after doing the basic data mining. So you see, I've taken data mining from data science and applied statistics on it to try to find out interestingness in the data. So levers for improvement. Explain the rise. Was there incentivization or de-incentivization in case of a fall? And nudge appropriately to make a daily habit. So for example, somebody may come in and say, oh, in 2017, week 11, we started a campaign for giving 20% discount on diabetes medicine, and hence there was a rise. So someone has to come and interact and see historically what was done. Now, instead of this rise, if there was a fall, consistent fall, then maybe you need to do the nudge with incentivization. So that's basically the actionability for someone on the ground to take, to do something so that this company would be top of the mind for the end user. By the way, top of mind is a very common thing in marketing. I've heard this phrase being used quite a bit, but to be data driven, to be top of the mind is also important, because you cannot flood everyone with promotional messages. They will start blocking you if you annoy people too much. So there's another theory about that and other studies on that. So I won't get into that, but just a brief mention. So I spoke about the e-pharma. I'm going to talk about Dhobiwala's order data and what can I do. So Dilip, who runs Dhobiwala.com, he gave me 5 months of data of e-laundry. It's a business that's centered around parts of Bangalore, and he runs it. And he asked me, what can we do for actionability of insights? Can you provide something? Just do what you can, right? Free for all. Find out what you can do. So some of the things you can do, which is typically done, is revenue. Like what needle would you move so that your revenue would increase drastically, right? What needle would you move, or where do you see your customer acquisition happening the most, and hence what would be a strategy to acquire more customers? And then unit economics, definitely something, if you know the costs and all of that, right? The operational costs, the real estate, and all the other costs, infra costs, is what would you need to do for each of your segments to be have the right unit economics, that is, be positive. And then, of course, there's recency, frequency, and monetary in, again, customer analytics. So these are some of the things that you can do given a body of data, order data, right? So what would you do? I mean, after again this talk, please feel free to try something and share your thoughts of what would you do if you got a body of data of this sort. So I'll only talk about revenue maximization, but basically in revenue maximization, I could see something interesting. Amount BD bin, it's bucket 5. I think the amount BD bin was when people would send a lot of clothes for laundry, right? Somebody came back from vacation and they have 20, 25 clothes, dump it all together and give it for laundry. That seemed to be that 4.29% of the total orders, but the revenue amount was 19.79, almost 20%. Now, very clearly, if this 4.29 is moved to 5.29, right, that 1% increment in the order percentage would impact this so much more tremendously. I mean, the amount, the revenue would go to 24%, right? So these are the levers that I could provide Dilip and his team, that maybe this is what you should focus on in marketing. This is where you give a nudge. Can you give a small incentive and increase your revenue? When you're working with, you want to see numbers, you want to see growth consistently, and you see a shortfall, or you see that you're kind of stagnated, what would you do to nudge and bring some quick revenue? So another thing was dry cleaning, right? Here, dry cleaning, and if they give up to 3 to 4 clothes, and all the payments were online, but if they give 3 to 4 clothes for dry cleaning, that's also one thing that you can incentivize. So wake up your dormant customers and so on, and they may suddenly realize, yay, there is a jacket I'd like to get dry cleaned, or there is a lehenga I'd like to get dry cleaned, and so on. So that's basically the lever for revenue maximization, or to nudge the revenue and improve revenue. I'll leave the rest of the metrics as an exercise. When I say exercise, I mean your creativity, and please share it. I mean, I may also learn a few things from you guys. So please do share it in the comments in the YouTube, or write to DataHour, and then they'll share it with me. I spoke about pricing, customer nudge, and maximization. All right. So I spoke about 2 use cases in the exploratory data analysis world. Somebody gives you data, you have a vague idea of what the business is like, and what would you propose? That was an open-ended question. Now, this one is a little more specific. Classification, creating rule-based classifiers on historical empirical data. I would not just call this a rule-based classifier. I'd also call this a case where data explainability is extremely important. And we'll jump right into the use cases. When in my startup, we got data from e-commerce companies, and there were things like RTO, RMA, and returns. And RTO is basically a return to origin. The global average is 16%. And I'll explain RTO again. Somebody places an order. The order comes to the doorstep, or the address is false, or anything that does not get the order delivered, and then it returns back to the warehouse or to the seller. Returns, that's the last part here, is where the user actually says, I don't want this product. I find it faulty, or I don't like it. And RMA was kind of a very, very weird thing that some of the e-commerce companies did, was that if the item was less than 400 rupees, and the user did not want to keep the item and wanted to return it, the return shipment and the warehouse costs were equal to the price of the item. So they would just say that, hey, I don't want to incur any more loss on this item. So Why don't you just keep the item and refund the money back to you? And there was massive abuse about this as well. These use cases are from real life and very interesting use cases. And how do you go about making a dashboard for your customer so that they can then realize and track things periodically and regularly, right? And take action? In this example here, brand name Apple, which is category mobile and tablets and cash on delivery. And this SHO fulfillment type, I really don't know what FCDOI means, but it's one of the fulfillment types. If I recall correctly, fulfillment type could be drop ship or from the warehouse or whatever. So this particular one, I really don't know what FCDOI is. But the takeaway is that there were 669 RTOs out of 989 orders. That's 64%. That is huge. Now, if data was given to you and you have to discover this, how would you discover such insights? I mean, good luck with OLAP drill downs and drill throughs and all of that, right? You probably will not get that far, and that to 6-level combinations, forget it. It's just combinatorially too expensive. But this oracle, this magic system, should be able to extract these points and bring it to your attention. So this is one example. Another example that we had was, one particular courier in the city of Hyderabad, negative margins on 14th of April, then 21st of April, again, another example of 14th of April. They were giving RTOs of 55, 53, and 52%. In this example, it seems like one courier company in Hyderabad was literally hurting the e-commerce platform. If you are an analyst, how would you chance upon this kind of information? I mean, Hyderabad on the whole may have been okay, but this drill within Hyderabad done by this particular courier in the pin code sub 5,000, that was bad. And that was kind of, the bad apple in otherwise the good city of Hyderabad, but things would have been hunky-dory. How do you identify this? Can an analyst stumble upon this by chance? I don't know. I honestly don't think so, because there are just way too many combinations. In the third example, and this is what I think an insights query screen should look like. And I've always said this: query for insights, not for information, right? You need this thing where you query for insights. So here in this case, it was an RMA example. And we had the starting date from 1st of April to 21st of April, and average at least 20. And so number of days is 21. This was auto-populated. So where was RMA really happening? And guess what? Pin code 1250, pin codes beginning with 1250, which I think is Haryana. I could be wrong. Consistently, right? They were just abusing the system. You look at the numbers here: 54% RMA, 38% RMA. 46 out of 100 orders were bad. 46 out of 110 orders, so on and so forth. So people were literally abusing this system. One day it went up to 56%. In the state of Haryana, tier 4 towns in Haryana, where app was used, again, 35%, 26%, 30%. I mean, the numbers are bad, 24%. 24% of your items are kept by the user, and you also give a refund. I mean, you're literally hurting your business, right? So no, we did not run to the 2 to the power n group buys. You cannot run 2 to the power n group buys. I can't write that many queries and automate. And even if I do that on the database, first of all, the time is prohibitive. Secondly, it's extremely wasteful, and that's not the way to do it. And I'll explain how I got the idea of how to build that oracle that would pull out information. So this is, again, I would like to emphasize that query for insights, And this is what an insights query screen should look like. Another example for RTO, average 35% for 10 days between 1st of April and 21st, I think. A number of days, at least 10. I think this was, I don't recall what this particular screen was, but this was actually a screen that we shipped to the customer. I think 35% at least for 10 days. That's what I think the query parameter was. But 21 days of data and RTO. 35%. Now, if you look at margin positive jewelry and watches when booked on app for cash on delivery, 35%, 30%, 36%, 37%. So consistently, this combination is bleeding your business. Another was pin code 5300, pin code starting with 5300, cash on delivery. If I don't recall what 5300 is, but it should be in Telangana, if I'm not mistaken, or could be in Karnataka as well. But yes, so again, very high RTO percentages. Tier 4 towns, an app, and the seller city was New Delhi. I think the subcategory was men's clothing. Again, very high RTO percentage. Could it be, that this particular seller in Delhi was being targeted by a particular seller in Delhi was being targeted by an ex-employee? We don't know. You'll have to then double click on this and get the actual orders and visually see what's happening. If you need to assign a story or come up with a story for this combination. Again, correlation is not causation. So, you found the correlation or you found a hotspot in data, but you still need to double click on this combination, get the actual raw orders and eyeball and see if something is very interesting here. Right? And there's scope for automation, but again, it'll be industry specific. Okay. So levers for improvement, accountability with the courier partners in Hyderabad, right? Would you allow RMA in Haryana? I probably would not, or at least I'd recommend not to, after seeing the data for Haryana. And discover and apply rules to block repeated abuse. This is another thing you should, you can get, you're discovering new rules as you go on, and you're building your rule-based, checks and balances a little stronger. So you wouldn't allow a lot of orders to be made. You'll allow a few orders to be made on cash and delivery and block it beyond that. So I will now go on to this use case, a quick check of time. We have 30 minutes done through the thing. But this use case is perhaps the one I'll get into maximum detail. I spoke to Ashok Shastri, one of the co-founders of DriveView, and got permission to show the analysis that I did about 4 years ago with DriveView, and how I made some recommendations. One of the best projects I have done completely by myself, right? It was real fun doing it all by myself, and the recommendations I made thereof. So Ashok called me one evening in May of 2018 and said, "Hey, listen, Vijay, I have a problem. A lot of people are downgrading my app, and I really don't know what's happening. Can you help me? Can you do some analysis on your own?" I said, "Sure." I sat down with Ashok and his team, got some data, understood the business better, and then realized that there were cases where a promise was made to the customer, but a driver was not available to fulfill that promise. And that is a pretty bad thing, right? I mean, unlike cab bookings, which is immediate, a driver booking is kind of scheduled. So you book 3 hours before or 5 hours before or something like that. Things have gotten much better. I mean, Ashok's DriveView today is phenomenal. I get a driver very fast, and I also have never seen cancellations with DriveView personally. I use them quite a bit when I'm in India. Phenomenal data, very clean data. Now, I had to make recommendations to Ashok. First, I had to explain the problem. and then make recommendations. Now, if you look at the data here, the row number 2, for iOS-based, orders, for usage of 1 hour or less in the city of Bangalore, in this zone 219, I think this should be Indiranagar, where there are a lot of pubs, or maybe even MG Road or Brigade Road. Popularity index 1, so it's a very popular zone. And on the weekend, very late at night, for a scheduled one-way trip, there were 43 cases where the driver did not was a no-show out of 114, which is a little less than, well, around 30%, right? A little more than 30%, but 71 were good. And this is obviously really bad. As a business owner, nobody wants to see any of this sort. It brings bad press, and then you need to start focusing on the customer confidence, which again costs the company a lot, and it takes a lot of effort to bring customer confidence, right? So this was a problem. Think about the ways you would go about solving, where you had bad count and good count and total count, and across about 8 dimensions or 9 dimensions of data. Again, I ran it through my wonderful Oracle and look at these extractions that are coming out, right? Out of 20,000 plus trips back in 2018, for this particular count of 18, where one particular zone on a weekend, very late at night, there were 83% cases where the driver was not found. That's huge, right? Again, 18 is a small number compared to 20,000, but here's this little tiny black dot in your data, which is getting you bad press. Small in number, but still bad. Another case, zone 399, very late. Right? It may not be a weekend, it could have been weekday as well. Again, 80% no show. So build many of these kind of rules and just automatically extract from the data. And I'll tell you something about the nature of the data. Sorry, my presentation skills are my diagram making skills are not up to mark, but I'm more of an engineer than or a scientist than an artist here, but bear with me. Here, if you see the interesting analytics for explaining the problem, those rules kind of lie here. I should explain again what this is. Here, the x-axis is the number of orders, so the total count, and the y-axis is the bad percentage count. Okay, so if I plot the total count to bad percentage count, I get these points. And here, if you notice very clearly, the interesting one, the explainability, actionability, they kind of lie in this mid-range over here. Yeah, they're not too small in count, and they're not too high in bad percentage. They're above the worst case or above the average case, but they are actionable in some ways. And then these ones could become the rule-based classifier. The ones, if there was a rule-based classifier that I built for every incoming order, I'd match it with the rules, and there are ways to make that match efficient, like a decision tree. And then you could come and tell the customer, hey, we've noticed that there's a 30% chance of driver no-show historically. Would you want to book a driver earlier also, or should we start looking 3 hours before to find a driver, and then get back to you? So we'll just temporarily, take your order. We're not confirming right now, and then it's going to cost you more, right? So you could play with pricing, you could play with supply positioning, expectation of supply, all of that. So yeah, this is one study that the mid-range tends to give you more high-level insights that you can convey to the business owner, whereas these ones actually become rules that you could, you can flask it and put it in line with your order management system. So I took some of the central rules and I just wanted to highlight a few interesting things that I noticed. And by the way, FIS stands for frequent item sets. I will be talking about that shortly. Weekend, very late at night, 27% bad percentage count. So drivers don't like to perhaps work with drunk people and the car smelling and all of that, and you know, that too very late at night. And again, one-way trip. I mean, the thing to notice here is this 3 is a subset of 2, but the one-way trip is not a deterrent given the weekend and very late. Because I say that because 27.4, which is the parent value of cancellation, is greater than 27.1. So given a weekend and very late, that itself is reason enough for cancellations. One-way trip, given that, not as much, right? Just a call out. How do you read this kind of thing and explain it? Summary of high-level findings. The city of Pune needed attention, right? Late night bookings on weekends is a big cause of concern. When the zone demand popularity is bad, when it's a zone that you get sporadic bookings, right? And it's a one-way trip, that's an area of concern. In Mumbai and Delhi, late night one-way trips, especially on weekends, is a concern. So top 5 or 6 actionable items based on the rules, by playing with the rules and then presenting it to the user without having to do the standard way of drill down, drill through, and all of that. And the opportunities, by no means is this study complete. This is still an open area for research, especially in the management sciences of the data science. Can we develop, given a subset of frequent item sets, to make a decision tree for simple visualization, maybe a 3-level or 2-level, so that we stark out like, this is bad, this is good, you know. And maybe one of the earlier presentations on DataHour by Priya Nair, she talks about how visualization is really important to stress your point to the stakeholders. So if you blend that visualization with frequent item sets, I think that'll be a huge win across the industry. How do you represent data to the customer, in this case, DriveView, for easy consumption and actionability? You know, again, 1, 2, 3, 4, 5. Can we automate the process in which, like, I got these rules, got these things by looking at the rules? Can we automate it in some way? Maybe a few levers here and there, and then that would be it, right? You don't need to drill down any further. So top level action in the business could bring a huge change to the customer confidence, and then the cancellations could drop significantly, at least half the cancellations to begin with at the end of the first month. And represent the combinations that are bleeding for the business, right? Only a few combinations, as I mentioned here. Zone demand popularity is bad, and the booking is a one-way trip. So it's not a popular zone and it's a one-way trip, then that's a combination, right? Each of these are combinations. So the levers for improvement was pricing, like surge pricing. If you remember Uber surge, when there is a supply-demand gap, maybe you know, DriveView could have put some more incentive for the driver, played with higher pricing for high supply-demand mismatch based on historical understanding. So that would be like, hey, it's going to cost you 2,000 rupees for a one-way trip from Noida to Gurgaon. Take it or leave it, you know, kind of a thing, because you're asking for a cab at 2 a.m. in the morning. And people sleep in the night. So, you know, things of the sort, right? I mean, the more the demand supply gap, the better the chance of playing with pricing. Setting the right customer expectations, right? Looking for a driver for a longer duration. Maybe you book a driver now itself and keep him sitting and pay him for the extra unused hours based on the rate. But at least you have the driver ready when you're ready to go back home at 12 a.m. At night. Supply positioning. This is important because if they incentivize late night work, you know, if a driver can make a week's worth of money in 2 nights. Why would that driver ever work during the daytime? So then all your drivers will start going there. So these are some of the things that you need to, do a round robin supply positioning and so on, based on the data, and then you need to monitor the data repeatedly. Quick check of time. Yeah, 12 minutes. I'll zoom through this Swiggy hackathon. I was the oldest member in the hackathon in 2018. We were given a data set and various columns for food delivery or food order delivery. I mean, there were 2 or 3 or 4 data sets, and I picked this one, and including a geohash index, which they had obviously obscured, so that when there was no real customer data, it was all obscured. And then we got to define a data science problem and solve it. So I picked the one for late deliveries. What makes an order go beyond 50 minutes? If I remember right, this choice would make the data set like a classification problem that would be very skewed. So very imbalanced, right? There were very few orders actually in the 3 months of data that took more than 50 minutes for delivery. But then I defined that problem. And then again, I applied the frequent item set based solution, and I came up in the top 16 out of 60-odd teams, and had to define the problem. I was the oldest participant. Yeah, so again, I extracted some rules and made some basic observations, very generic, and presented it. Like all this analysis led to one slide. And this is it. This is what happens when your orders, what make your orders go beyond 50 minutes for delivery. So I'm now going to talk about the background and research. Okay, back in 1994, Professor Jeffrey Ullman, Dr. Anand Rajaraman, and Dr. Venki Harinarayan, at Stanford, they have this publication on data cubes and data warehouses. It's probably one of the most quoted papers in the history of IEEE or ICM, I forget which one. And Anand Rajaraman is perhaps like the Amitabh Bachchan of data science, if you may. He started Jungly.com, sold it to Amazon, and started, I think, the company Cosmic Labs that was bought by Walmart Labs. So yes, he's still a professor at Stanford, and he's an investor and so on. And Professor Ullman is, probably the Bhishma Pitama of computer science, if you may. A really big name, really, really big name, a fantastic professor. Their paper became a landmark. And the focus in 1990s and early 2000s was query optimization and indexing for quicker data retrieval, right? That seemed to be the focus. People would aggregate data into mini cubes of data, and this was done in the 90s and still practiced in many companies, in fact, all companies, right? And I've seen that even like very, very recently. So people aggregate data. And then, of course, the evolution had MapReduce, working with really big data, Hadoop, Apache Spark, and so on. And there are companies like AtScale and Keywas Insights, which kind of take care of that end of the spectrum, where they try to make your queries much faster. Otherwise, I remember back in 2012, we fired a query on Hadoop. A retrieval, not even building models. Another beautiful parallel track in the data stream was this a priori algorithm by Professor Rakesh Agrawal and his student at that time, R. Srikanth, who is Ramakrishnan Srikanth, who is I think a fellow at Google now. Brilliant paper, again groundbreaking. One of the most quoted papers even today. Even today, if you look at those referring to the a priori paper, it's like you'll still find hundreds of papers in the last 3 or 4 years that refer to the a priori algorithm. Very important algorithm. Basically, they came up with the idea of frequent item sets and association rule mining. Highly underrated And, the world keeps thinking about, when professors or textbooks explain this, I think they go by the Walmart example or another store's example, where beer and diapers sold surprisingly frequent on weekend nights. And then, that was an observation, that was a correlation. And then, of course, there was somebody who did analysis to explain, oh, daddies want to watch the football game on Friday night, and they have kids, and so they bought beer and diapers together. So that's a very famous story. Everybody quotes that, and for God's sake, frequent item sets and association rules is well beyond beer and diapers. There is an implementation called eClap. I think it's used by R. And that implements the a priori TID algorithm. Christian Borgelt is another researcher somewhere in Europe, and he implemented this in C++. And then there were a lot of publications after that, FP Growth and Spade. Again, most of these papers were used for, raw data. No one thought of, or few thought of using it in aggregate data. And that's where I take papers from the earlier data warehouse and data cubes, and papers from the, a priori kind of association rule mining, blend them together, and the result is the oracle that is extracting only those insights that are important for explaining a problem. So, of course, this ML and AI and everything in between to the analytics world. But Ramakrishnan Srikanth, when he interned at IBM, along with Ali and a few others, wrote this partial classification using association rules. And in a sense, the example I gave of DriveView, the example I gave of the RTO, and even the Swiggy example are extensions of this model, right? It's basically using association rules for building partial classifiers, and which are empirical in nature, that as in this is what happened, right? So a short note on a priori algorithm, initially proposed for market basket, works in two parts. First, compute the frequent item sets, FIS, that is a combination of level and combination, and then computes association rules and uses lift and confidence. And this is part of the theory of association rules, which I won't get into. But I hope someday someone does a detailed talk on this, or if there's already one on association rules, if someone can, on DataHour, if you can bring it to my attention, I'd really appreciate that. And it's used in quite a few places, this association rule mining. What's new then? I blended the fact table in the data warehouse and a priori, like data mining, to ask questions via metrics. So I ask questions via numbers instead of using the traditional dimension-based OLAP or OLAP operations of drill down and slicing and dicing. So I'm getting directly to the point. Hey, just tell me the answer. Don't tell me what is it by country, what is it by age group. I don't have the time for that, right? I want the answer directly. So I blended these two together effectively, and I'm still in the process of identifying the most useful nuggets of information which are statistically significant and are short in size for summary for consumption. I use mutual exclusion within a column dimension for reducing candidate generation. This is getting into the details of the algorithm, but basically an item delivered to Mumbai is not also going to be delivered to Delhi, right? They're mutually exclusive. So city Mumbai and city Delhi would never be joined together. They would always be mutually exclusive. So that helps speed up the algorithm significantly. And I built nuggets of truths to ask questions of metrics, nuggets of truths. So that way, in investigations, things will be faster and people can get a high level understanding as well. Yes, when you think of a priori, think beyond shopping cart and think beyond beer and diapers. If you read that example, just laugh at it now. A priori can be used on not just counts, but also additive metrics like revenue, profit, spend, and so on OLAP cubes and aggregate tables. And yes, frequent item sets in a priori is just a form of automated group by in SQL. So all those who are learning SQL or use SQL in your daily work, you probably do a lot of group by. Here, a priori is actually doing that for you. It's automating it, but it's removing the long tail based on a support threshold. And what does a frequent item set look like? It looks like it's got a level, that is how many combinations, and it's got a rule, which I call FIS, weekend, very late, and scheduled. And it's got metrics, M1, like bad count, good count, total count, bad percentage. So, of course, bad percentage is a derived count, and so is total count. All I need to do is compute bad count and good count, and then add it to form the total count, and then compute the bad percentage count. And exploratory analysis solution, here's kind of what you could do if you're in the engineering world. You have periodic fact data or OLAP cubes. You run my Oracle engine, which we called GIST, G-I-S-T, generalized item sets, or PRESI as in concise extraction of content within a story or a big paragraph. And that's a modified a priori engine. You get the frequent item sets, load it onto Elasticsearch or PostgreSQL with the text-based search enabled, text index. And then your dashboards are powered off the Elasticsearch. So this is one way you could build an end-to-end solution that's periodic, and you can also extract interestingness from the data periodically, and yeah, take it from there. And how do I build classification? I take the OLAP cube, probability that there is a bad count, the given bad count, given a prior, that D is the data set, that given a bad count. Here, D is a data set given a good count. I take frequent item sets on both sides. I get the frequent item sets, and then I do a full outer join between bad count to good count. And then I can build my rule-based classifier. So this is kind of the high-level process of how we can do that. And now I will quickly jump to population healthcare analytics, which is also a very important field. But more importantly, here again, you would see the problems, and then you'll see the relation with frequent item sets based mining. So what are the questions you want to ask? You want to ask, what are the next diseases that a patient needs to be tested for? So let's say a patient walks in with high blood pressure and diabetes. What are the other common conditions that occur? What is the risk probability of this patient contracting a rare or an expensive critical disease? Which diseases occur together the most? And there are people who study disease patterns, so researchers would be interested in asking all sorts of questions. And then how to catch fraud. Sorry. How come such disparity in treatment costs for the same health conditions? So let's take a case where somebody who's two people who are age 60, both of them with diabetes and high blood pressure. But one person's bills were significantly higher and the other one was, expected. So how do you catch fraud? The co-occurring diseases, is a drain on insurance companies. There are quite a few disease conditions and patients that they may be small in number, but they really drain the insurance companies. So identifying those. There are many, many more questions in the space of population healthcare analytics. And what does the EMR patient data look like, which is basically the feed for population healthcare analytics? You have a patient ID, you have age group, gender, ethnicity, so on and so forth, some data based on the patient profile. And then you have 17,000 ICD codes. ICD codes are, I think, international codes of diseases. He said, I keep getting this pop-up of users.
Hi Vijay, just sorry for the interruption. Guys, I have launched the feedback poll. Kindly do participate. Yeah, Vijay, you can continue.
Yes, Sid, I'm sorry. I think I'll go 10 minutes or 12 minutes over.
No problem. You can go ahead.
Okay. Yeah, so this is a big wide table, and it is also, you have say 25 million patients, and now you want to do healthcare analytics, right? You can't use SQL because, I mean, you need to know the column names upfront to actually go write queries. You can't really, SQL is, yes, it's useful, but it's not adequate, right? So what do you do there? So frequent item sets work there as well. There are solutions from Spark. There is a solution by SON. I think N stands for Navate. I forget what S and O. There are three scientists who came up with a big data solution for this. Computationally, this is very expensive on big data, and you got to keep running, especially if you want to keep running it on subsets. So suppose you've isolated like rare disease. Now you want to compare occurrence of that rare disease and other conditions that occur with that rare disease. You probably want to run these kind of frequent item sets repeatedly. So here I would recommend, I mean, I started working shortly after leaving Google, I started dabbling with data sketches, which is an invention at Yahoo. And I use data sketches for getting approximate frequent item sets for very large data. So data sketches is a probabilistic data structure, and it's quite fascinating in the sense that, let's go to the next example. I'll skip this slide and come back to this. So imagine you had a bit vector, and each of these bits were like a transaction ID. So transaction IDs occur, and now you want to see for City Mumbai, hey, the third transaction was City Mumbai, the fifth transaction had City Mumbai, the sixth one had, and so on and so forth. So if you want to find how many transactions for City Mumbai, you just have to count the number of ones, and you can say, hey, 10 transactions for City Mumbai. Right? So this is a bit vector, but a theta sketch, which is a probabilistic data structure, is this magic 4 KB thing, which can hold large amounts of data, but the caveat is that it will be with 98% confidence, it will give you an answer which is within 2% range. So example, which, this is a statistical way of doing things where you say margin of error, and you say with 98% confidence, the value is between, I don't know, some numbers, 7 million and 7.02 million, right? So that's what theta sketches does. And it acts like bit vectors. So you can do and, or, not, bitwise operations you can do on the theta sketches. So here's theta sketches, datasketches.apache.org. And why was it invented? It was invented as an improvement for HLL, and I'll explain what HLL also does. It's got the same use case as theta sketch. It's basically used for unique counting in the big data world. We had this very crazy problem where we had to count the number of distinct users who had visited yahoo.com in a month, right? And distinct users who visited yahoo.com. I mean, every day there are billions and billions of hits on yahoo.com. And you can't just add up the numbers of each day. You cannot, because that would be double counting, because a person like Vijay would have gone to yahoo.com on Monday. He would have also gone on Tuesday. And then if you count the values of Monday and Tuesday together, you would count Vijay twice. So HLL was like, HLL solved that problem, but it had some drawbacks, or there was some more desired features. So theta sketches was invented. And sketches give approximate answers really fast. And what sketches can do is assume sketches to be like bit vectors. You can add the results of Monday and Tuesday, and you would not double count in this new sketch. So that way, that's why it was invented. But now I see use for it in frequent item set mining. And this is an area of research that I strongly propose. There are some recent papers that talk about this. I basically use theta sketches with the ECLAT, A priority TID algorithm kind of a method. And I populate a theta sketch for every dimension and value combination. So I can say city Mumbai and gender male, and I can do an and between them, and I'll get city Mumbai and gender male. So I started exploring this with Professor Anirban Dasgupta at IIT Gandhinagar, who is one of the original inventors of theta sketches, along with Lee Rhodes from Yahoo Research, and one of my friends, Chinmay Pradhan, who is the founder of PySquare.io, and he's an entrepreneur. And I'll just give you roughly what the FISs look like. Each of these E78, Z00, Z68, these are diseases. Okay, you can go look them up after this call, but each of these are diseases. But for people having these 3 diseases in the data set that we had 1,636 people. Again, this is an approximate count, but most likely the answer will be within 2% or 4% of the 1636. And it's okay not to have exact answers, because you want to get directional information as against exact numbers. Here I use the association rules to basically, I computed association rules. And if you see here, I've got lift and I have got confidence, right? Antecedent to consequent confidence. I know these names are a little heavy, but basically just simplifying it, right? Given that you have somebody with M81, the likelihood of that person being a woman is 90%. And I can say that this is significant because the lift is greater than 1.1. That's generally the taken norm. There is a lot of theory on this. There are professors, Professor G.A. Yan and also a couple of professors in University of Chicago. They've done some good stuff on this. And yeah, I encourage you to read this. This is a very powerful and underestimated thing in the field of data science. I could also make a rule-based classifier. So here I could say that if the age group is greater than 60 and the patient has E11 disease, then they have N18 with 42%. Now, obviously, if somebody walked in with this, I would check for N18 condition as well, right? And all these kinds of rules. Now, this becomes available to a doctor, a healthcare provider, their fingertips, where they could ask a question that, given this condition, what are the next top 20 conditions that I should look at? Right? And again, this cannot be SQL because you don't know out of the 17,000 diseases, which 10 would give you the answer. Again, some more examples. I'll just skip this to go real fast, but if the patient was a female and had E78 and Z85 diseases, C50, there was a 31% chance that they would have C50 as well. So again, something to go check. Right? And now we'll move on to the last case, automation with data. Quick check of time. I'm already 5 minutes over. I'll try to finish this in 5 minutes. But I'll tell you a big problem that happens in distributed systems. I know I'm jumping from business to core engineering and distributed systems, but that's the nature of the jobs I've been in. So I've been kind of lucky. But very often what happens in large internet companies is that you have engineers who build these wonderful, teams that build these wonderful distributed systems. You don't see it. And a simple email on Yahoo Mail or Gmail, the entire number of servers that request your open of a mail or sending of a mail touches is huge, right? And anything could break. So we have these engineers who go on call and they set alerts on CPU utilization, memory usage of each machine and average, latency, that is how long did the response, request to response. They keep tab of the 50th percentile all the way to the 99.5th percentile. Some cases also keep the 99.9th percentile. And then this queries per second, how efficient is your system, queries, TPS, transactions or queries per second, and the error rate. And they have exhaustive dashboards and graphs that are made available for debugging. And this is a problem because it's extremely overwhelming. And if you've ever been on call, you may get a problem at 2 a.m. in the morning, and you're groggy, you're sleepy, and then you have to see these dashboards, and you have to do some root cause analysis to find out what's happening there. So some background: latency, TPS, QPS, throttling, error rates are all related. Each one impacts the other. Assume that the data is in time series and follows some normal distribution, and for all cuts of data, right? So you can even apply a simple one-level group by or an a priori level kind of thing. And each of those nuggets would have kind of a bell curve. So that's an assumption. And at the point of alert, is there a spike, or is it linearly increasing? So you can auto compute this without seeing it yourself. You don't have to click on it to inspect it. You can automate it with fundamental statistics and make your life much easier. So here's an example what to alert when. So you set an alert for 12.6 QPS. And you have an upstream 1, upstream 2, and upstream 3. So briefly, what is an upstream? Upstream are those systems calling your system, and this is your system under observation. And you got an alert of greater than 12.6 QPS. Right now, upstream 1 was pretty consistent at 2.1 QPS. It rarely increased, and then on the day 15, the day of alert, it went to 2.2. Upstream 2 dallies between 3 and 3.1, and on day 15 it was 3. Upstream 3, it's 7.18, 7.19, it's some, and then it's 7.4 on again on the day of the alert. Now, if you had to sort as to which of these three in what order would be the root cause, I would pick based on the z-score of the upstream, the alert point. I would actually pick upstream 1 as a first reason, because it was kind of steady and rarely moved. So the tolerance for change is the least, in my opinion, and that would be the reason number 1. Reason number 2 would be upstream 3, because even that is 2 sigma, more than 2 sigma. I mean, 7.4 is greater than the largest number seen before. So you could say that it is 2.37 z-scores score is a large number. But I would still say that based on my earlier expectation, 2.2 is cause number 1 and 7.4 is cause number 2. Now, if I could automate this for the user, the on-callers would find it so much easier, right? They often, battle with a lot of pressure, this incomplete analysis, there are too many graphs to click on and various cuts of data to see. Practically, this is impossible. and I mean, do you really need that kind of visualization for everything? Yes, you do need visualization while explaining something or while putting it in a report, but your ability to explore via visualization is perhaps a very bad idea, in my opinion, because there's too many things you've got to click on. So there is, huge opportunity to automate. And your best friends are z-scores and linear regression. And identify frequencies of a perfect storm. And what I mean by a perfect storm is no one of the upstreams were really high, were more than, say, 1.5 standard deviations. But on the fatal day, 3 of them came with 1.4 standard deviation. So you got a perfect storm. All 3, dumped their requests kind of at the same time, which overwhelmed your system. So there are ways, these are the things that you should be looking for, and you could automate and then explain very easily in the dashboard, and then use visualization, to explain the problem. So possible flowcharts for RCA you could make for root cause analysis. You could, what changed statistically QPS, traffic volume, message size, latencies, and so on. What statistically changed for the downstream? Did you get a high error rate from one particular downstream? So maybe one database server was down, or the database server started acting up and was slow, so your latencies increased. So if your downstream latencies increase, your response time latencies to the upstream increased. And based on z-scores and steep slopes, prompt the user with visualization to do RCA, to do root cause analysis. So once you see something rising and you've not set an alert, that is what should get your attention to begin with. That's something spiked without you noticing, and or something is rising consistently. And this is what you should actually focus on to trying to make sure it's stable. If these had not spiked, would alert levels have been breached? So when would alert be breached? Hey, you are 2 days before your alert level breaches based on the forecast of the current slope. So anyways, I know I've taken a lot of time. I will try to conclude very quickly. Books and resources, again, I can't emphasize Mining Massive Data Sets by Professor Rajaram, Professor Ullman, and Professor Joe. Data Mining Concepts and Techniques, fantastic book by Professor Jiawei Han. I think this is the #1 book perhaps in the world in data mining. And in fact, one of the improvements to a priori, which is FP growth, was proposed by this professor and his team, and award-winning professor. Brilliant book, and filled with statistical techniques on data. And then Statistics Informed Decisions, 3rd edition. I mean, I mentioned this book last time as well. It's a book I would carry with me wherever I go. Really good book. So yeah, that's I'd conclude with the takeaways. Value retrieval of insights over retrieval of information. And that should be a last mile of analytics. And it is empirical. Empirical it is itihas. It is what happened. It's not a theoretical model. It is what you extracted from your data. It is empirical, right? And this is exactly what happened before. Start thinking beyond OLAP and SQL when you think about information or insights retrieval rather. Solve problems in an explainable way. Try to put a spin and explain the problem to the stakeholder well. And you can automate a lot with data. And it's easy to follow up where the remedies are effective or not if you do things a frequent item set based way. So these are some of the takeaways I hope to convey. And if you have any questions, if you have some free bandwidth for open source work, shoot me an email. Theta Sketches and if of course Theta Sketches is interesting to you, you can shoot me an email. We see what we can do. And if any of you are interested in implementing any of these solutions, I have a license agreement with Chinmay of PySquare. He can implement any solution that you actually need from this if you found any of this useful. So with that, I will conclude and I will open up for questions. And I see quite a few, not too many Q&A. Let's chat.
I think, Vijay, all of the questions are posted in the Q&A session only.
Okay,
So
cool.
You can, yeah.
Can you explain how often the correlation coefficient checking for linearity is sufficient? Good question. Very good question. It was my lower bound is being linear. If it's more than linear, then even more so that you can check for linearity. One thing I do for checking something that's more than linear is take 5 points or 3 points, 5 to 7 points at a time in the data set. And if the slope changes, and if there is a rate of change of slope, and the rate of change of slope is a straight line, then I can say it's quadratic in nature, or it's to the power 3. If I repeat it again and again. But yeah, my requirement was more business than to be accurate. So that's basically, it was okay for me to know that there was linearity without having to look at it. I hope that kind of answers your question, but your concern is absolutely valid. And there are many ways to handle it. You can be creative. There are papers that are beyond my reach, but you should try to find out. And if you find them, please share it with me as well. Shubham Goindwar, sir, sometimes we get data at which we don't have any idea about the thing, like sometime in fertilizer data, which do not know to us. Okay, I think I understand the question. You don't know the domain, right? You don't know fertilizer data. You don't know anything about fertilizers, right? But I mean, somewhere your common sense or some common knowledge would help you understand, hey, effectiveness of fertilizer perhaps is a question. I don't know anything about fertilizers myself, right? But basically, if let me try to relate it to the 0-1 knapsack problem, where an item has a weight and a value. So here there's a 1 kilo of fertilizer. It costs something, which is like the weight, and its yield per acre is so much, right? Which is the value. So you can kind of come up with some sort of business understanding. And if you don't, you should ask. I mean, I don't know how else to answer that question. Luis Herrera, hi everyone. Please, it's possible to share this recording. Yeah, I think so. It will be posted on DataHour's video. How to build a data model. Wow. How to build a data model. I mean, if by data model, I'm guessing you mean the schema to the input data, right? And that's typically defined by product managers, and that's defined by people who start building the data or start collecting the data. Why I call frequent item set based analysis as the last mile of analysis is because the data is already available and the model is already available. But yes, data models are built by people who start off with a hunch and of their some subject matter expertise and so on. Yes, please. What is the Oracle you run? Next question. It is frequent item set based rule mining. But then I get a little smart about it. And I basically post a question. I can perhaps make a video of running it on my machine and showing you for a particular data set what it does. You know, it just extracts something out. Next question. What are the regular place you get these research papers and are in line with your requirements? Ooh, Google search. Google Scholar, Google search. I sometimes ask professors, I cold mail and ask professors, I ask researchers. I'm quite shameless when it comes to asking people. So I encourage you to, don't bother them, maybe one email, and then explain your problem, read your problem really well. If you write a large email, no one's going to read it. So maybe, a 3-4 line email. And then, they can point you towards the right direction. But yes, Google search is my number one go-to place for finding out research papers. And that's how I validate a lot of my work. In fact, the work I've done has been attempted back in 2006 by a bunch of French researchers and a few others. And it continues to happen. I mean, 2010 to 2021, I've seen quite a few papers on min sketch, and frequent item sets. So that's another thing. Thanks, very interesting and informative. Do you get this data for systems RCA? So yes, from the server logs, that's correct. Companies like Yahoo and Google are much more, they have very mature systems, phenomenally mature systems. So you have them not just from server logs, from the server logs, they've been extracted into and put into a database, and there are beacons of information that are sent. It depends on the maturity of the organization, but yes, you would get these from the server logs for a smaller organization. But there's a good chance that cloud providers like AWS, Google Cloud, GCP, and Azure, they have mechanisms to provide this data to you based on the performance of your system. So yeah, with that, I have no further questions, and with that, I think we can end the session. And again, I'm sorry I went 22 minutes over, but yeah, uh, that's basically it for today.
Okay, yeah, I guess we have answered all of the questions, I guess. So yeah, but okay, so one question, Vijay, from my side actually. Okay, so like I've been, touch with director like you, and there are other guys who are lead data scientists of their team, or there are managers of their team. You know what they suggest to the freshers that you guys don't like. Okay, coding is okay in data scientist, but you must focus, more aligned to business problem. You must cut short the business problem, break down the problem. You must understand the business problems, right? And other side, if we talk to any of the data scientists who work under any of the team, they more aligned to the you must focus on these models, you must work on these models. So as a fresher, who must I follow, like, to the product managers, to the director I like you, or the data scientists who work on a team? Whom should I
Very
follow?
interesting question. If you see yourself getting an MBA, follow the boss. If you see yourself getting a PhD, follow the data scientist. Um, but uh, there's no right answer, to be honest. I mean, somewhere trapped within me is a scientist who didn't get a PhD. Somewhere trapped within me is an entrepreneur who didn't become a successful entrepreneur. So it's a conflict, and I think you need to solve that conflict. Business cases are important. One takeaway, I mean, and what you're asking with data science has been asked of me, or happened to me as software engineers, right? Back in 1995, 96, when I started my career, there would be people who would say, hey, focus on the business, don't focus on technology. Technology comes and goes. And I was like really good with Power Builder and Sybase and Visual Basic and all of that, um, uh, Oracle databases and all of that. And my coworker who was senior would keep telling me that, hey, you should focus on business. Um, why it seemed right till 2005, 6, because I could not keep pace with every new, hey, there's, from C, I moved to C++, I moved to Java, I moved to, oh man, there's Golang right now, there's Python, I
Yes.
can't keep pace, right? But on the same note, the likelihood of keeping a job, forget about growth, but keeping a job is higher if you are more hands-on. So that's where the engineering side would be more useful, and hence the data scientist would be right. But from understanding a bigger picture and a possible growth, I think the director or the manager is right that you should focus on the business as well. Um, Hard to say where you would move, but I think you should keep an eye out on both sides, right? If data science is your passion, try a Kaggle competition or try some data with some data set to do something very interesting. Make it fun for yourself. That would be my advice. I mean, you should focus on the job, but also do something on the side. I know you'll have to make time for that. I mean, 8 hours a week of some sort, but yes, that's the only suggestion if you want to satiate both sides of things. Did that help answer?
Yeah, actually, it really helps me. It's just so.
Absolutely. Thank you so much. Yeah.